Welcome to G Fun Facts Online. Imagine an uneasy slumber broken by a fiery awakening. This is the dramatic story of long-dormant volcanoes. Scattered across the globe, these sleeping giants can lie quiet for centuries, even millennia, their slopes covered in lush vegetation. Yet, beneath this tranquil facade, the Earth's inner turmoil can set the stage for a violent return to life. Today, we're journeying into the heart of the Earth to understand the mechanisms that can stir a volcano from its long rest, examine the telltale signs that herald an impending eruption, and recount the dramatic stories of volcanoes that have spectacularly woken up, forever changing the world around them. To understand why a volcano reawakens, we first need to know why they exist at all. The Earth's crust is broken into massive tectonic plates, constantly in slow motion. It's at the boundaries of these plates where most volcanic activity occurs. Where plates collide, one can dive beneath the other, melt, and form magma that rises to create volcanoes like those in the Andes. Where plates pull apart, like in the East African Rift, magma can rise to fill the gap. And sometimes, a plume of exceptionally hot material from deep within the Earth creates a hotspot, forming volcanoes like those in Hawaii. This magma collects in a subterranean reservoir called a magma chamber. The processes within this plumbing system determine if a volcano is active, dormant, or extinct. So what does long-dormant truly mean? An active volcano is erupting or has recently. An extinct volcano isn't expected to erupt again because its magma supply is cut off. But a dormant or sleeping volcano is the one we're focused on. It's not erupting now, but it's expected to in the future. The line between dormant and extinct can be dangerously blurry. Mount Pinatubo in the Philippines was dormant for over 500 years before its cataclysmic 1991 eruption. Mount St. Helens was quiet for 123 years before its 1980 eruption. This teaches us a critical lesson. A long rest is no guarantee of permanent inactivity. So what wakes the giant? The most common trigger is a new intrusion of magma. Many dormant volcanoes have large bodies of magma that are too crystalline and viscous to erupt. They're essentially solidified. The catalyst is a fresh batch of hotter, more primitive magma from deeper in the mantle. This process, called magma mixing, is a potent trigger for a few reasons. First, it reheats the resident magma, making it more mobile. Second, the heat causes dissolved gases like water and carbon dioxide to bubble out of the solution, a process called exsolution. This drastically increases the pressure, like shaking a bottle of soda. This combination of more magma and expanding gas creates a pressure cooker effect. If the pressure exceeds the strength of the overlying rock, it fractures a path to the surface, and an eruption begins. Evidence from the Soufriere Hills volcano in Montserrat, which reawakened in 1995, showed that an injection of new magma was the trigger. Volcanoes and earthquakes are also intimately linked. A large tectonic earthquake can act as a trigger by altering the stress in the crust. The shaking can dislodge a plug of hardened lava in the volcano's conduit, or the stress change can literally squeeze the magma chamber, forcing magma upwards. A striking example is the Krasheninnikov volcano in Russia, which erupted in 2025 after 600 years of dormancy, an event scientists believe was triggered by a massive magnitude -8.7 earthquake offshore. Because these awakenings can be so devastating, a key focus of modern volcanology is monitoring. Scientists use a sophisticated array of tools to detect the subtle precursors that signal magma is stirring. These warnings can come days, weeks, or even years before an eruption. The first sign is often seismic. The movement of magma cracks rock, creating small earthquakes. An increase in their frequency and intensity is a red flag. Magma can also generate a continuous, humming-like vibration known as volcanic tremor, a strong indication that magma is flowing. The 1980 eruption of Mount St. Helens was preceded by 2 months of intense earthquake activity. Next, there's ground deformation. As magma accumulates, it pushes the ground upward and outward, causing the volcano's surface to swell. While often imperceptible to the naked eye, it can be precisely measured. Networks of GPS stations track millimeter-scale changes. Tilt meters measure minute changes in the ground slope. And a powerful satellite technique called INSAR can create detailed maps of ground movement over a wide area. This was famously seen at Mount St. Helens, where a bulge on its north flank grew at 5 feet per day before the eruption, a clear sign of magma intruding high into the volcano. Scientists also sniff for clues in the air. As magma rises, dissolved gases escape. A sharp increase in sulfur dioxide, or sulfur dioxide, is a strong sign that fresh magma is nearing the surface. Before the 1991 Pinatubo eruption, sulfur dioxide emissions skyrocketed from 500 tons per day to 5,000 tons per day in just a few weeks. Changes in the ratio of carbon dioxide to sulfur dioxide can also indicate that a new batch of deep, gas-rich magma is on the move. Finally, scientists take the volcano's temperature. A reawakening volcano often heats up. Satellite thermal imaging and ground-based thermal cameras can detect new hotspots or an increase in the temperature of existing steam vents, known as fumaroles. The science comes into sharp focus when we look at real-world examples. After more than 500 years of slumber, Mount Pinatubo reawakened in 1991, becoming the second largest eruption of the 20th century. The warning signs were clear and escalating. It began with steam explosions, followed by hundreds of small earthquakes per day, and that massive increase in sulfur dioxide emissions. By early June, a lava dome began to grow. Based on this data, scientists issued warnings that enabled the evacuation of tens of thousands of people. On June 15th, the volcano exploded, sending an ash column 22 miles high and unleashing pyroclastic flows, searingly hot avalanches of ash, gas, and rock. Tragically, a typhoon hit at the same time, mixing with the ash to create destructive volcanic mud flows called lahars. Over 840 people died, but the timely evacuation is credited with saving at least 5,000 lives. Another watershed moment in volcanology was the 1980 eruption of Mount St. Helens in Washington state. After 123 years of dormancy, the warning signs began on March 20th with a magnitude 4.2 earthquake. The mountain was then shaken by thousands of quakes, and the ominous bulge grew on its north flank. On the morning of May 18th, a magnitude 5.1 earthquake triggered the largest landslide in recorded history, as the entire weakened north face collapsed. This sudden uncorking of the volcano unleashed a massive lateral blast that traveled at over 300 miles per hour, flattening nearly 600 square kilometers of forest. The disaster claimed 57 lives and transformed volcano science, spurring huge advances in monitoring. Not all crises are short-lived. The eruption of the Soufriere Hills volcano on the Caribbean island of Montserrat began in 1995 and is still ongoing. After centuries of dormancy, it began with earthquake swarms, then steam and ash explosions. The eruption signature became the steady growth of a lava dome, punctuated by terrifying collapses that generated pyroclastic flows. Over time, the capital city of Plymouth was completely buried and abandoned, forcing 2/3 of the population to permanently relocate. It's a profound example of the long-term challenge of living with an active volcano. Then there's the story of Chaitén volcano in Chile, which erupted in 2008. This was a major surprise. It had been dormant for over 9,000 years and wasn't being monitored. The first seismic activity was detected only about 36 hours before the eruption began. The explosive eruption sent an ash plume over 20 kilometers high and led to the permanent relocation of the nearby town. It was a stark reminder that even volcanoes with very long rest periods can reawaken with little warning, and it spurred the Chilean government to dramatically improve its volcano monitoring program. Living with these sleeping giants is not just a geological problem, it's a societal crisis. Communicating the risk is a major challenge, especially the uncertainty. Scientists and officials must build trust and encourage preparedness. The successful evacuations at Pinatubo show the life-saving importance of heeding warnings. The aftermath, as seen in Montserrat, can be a prolonged crisis involving not just rebuilding, but addressing deep social and economic trauma. The reawakening of a long-dormant volcano is a powerful testament to the dynamic nature of our planet. While they pose a significant hazard, they are a fundamental part of Earth's cycle. As our understanding of the deep-seated forces of magma, heat, and pressure grows, so does our ability to interpret the warning signs and save lives. Living in the shadow of these giants requires a profound respect for their power and a commitment to science and preparedness. The uneasy slumber of a dormant volcano will always command our attention, for its awakening is a visceral reminder of the restless energy that lies just beneath our feet.